Right. So the EBS, I hope you guys have understood Amazon EBS. We are going to look at S3 and EFS now. We discussed EBS yesterday in the lecture class, and you have a small lab to do. You just did a small lab as well. So you should have some concepts on that. If you have any question, you can always ask. Let's move to Amazon S3, right? So let's go to Amazon S3 and we will use the free tier account to play with Amazon S3 as well. Where's S3? Yeah. So we have all done this, right? That lab 4 you just finished, EC2 instance, attach DVS, created a snapshot, and later you can create a new volume using this snapshot and again attach. That's what you guys probably did with lab, right? Now let's look at simple storage, also Amazon Simple Storage Service. So in short, Amazon S3. Now Amazon Simple Storage, you can see a bucket here. It's a bucket type storage as opposed to EBS we just looked at. It's in EBS is a block storage. Now this is bucket type storage, right? Bucket type storage means if you have to make changes, so you uploaded a file, for example, right? It's a storage device. What are you going to do with that? You are going to store your data, files, whatever you have. If you so yeah, S3, right? So bucket storage would mean that if you have to make changes, you can't just go and make changes. Let's say you have a file there, you have stored a file, and you can't go to if you want to make a change, let's say that file has multiple strings and everything, you just want to make changes for a string, you want to update a string, and there you basically have to create a new file in bucket, right? Any small changes creates a new file. You have to create a new file. The entire file is updated. In block storage, EBS, which you work with, you can simply go to that block and update that block. Or you can simply go to the location where it is stored, which is called block, right? If you have make small changes, you can find that block and update it. That's the main difference between EBS and storage service. Now, S3, right? So you could guess which one is faster. Obviously, EBS will be faster, right? Every time you have to make small changes, you end up creating a new file. You are updating the entire file, which is basically equivalent to creating a new file. So it is going to be slow. However, it has many uses, which kind of makes it very useful and most used storage service perhaps in the AWS storage, among the options that AWS provides in storage, right? So you see data is stored as a buckets, right? You have virtually unlimited storage. The only limit here is you can only upload or you can only keep into these buckets a single file. If you have a single file, that cannot exceed 5 terabyte. Otherwise, there's no limit. You can store as much as you can, right? It's designed for 11 nines of durability. Now, have we heard 11 nines, 3 nines, that kind of unit before? So it's basically when someone says 11 nines, it's like after decimal, you have that many digits. So for example, if we say 11 nines, it's 99.11 nines, 99.99999 up to 11 nines durability. So almost 100%, but it is not 100%, right? You'll have small risk still, that it will not be available or durable at some point of time. But 99.99999 99 decimal. After that, 11 nines is almost 100, you can say. We have granular access to buckets and object as well. So if you keep hundreds of files here, let's say, you can change properties. You can configure properties for each of these files. So you have a granular access for each of these objects, right? Any object, anything, any file you upload, it becomes an object. Remember what is the difference in object and other storage? If you make changes to that object, to file, you are essentially creating a new file. Yeah, we just have to remember that, right? So S3 offers range of object level storage classes that are designed for different use cases. You can see Amazon S3 standard while working with in AWS management console. We'll see that as well. It's very simple, but we just need to understand, right? So the standard is a standard bucket, right? General purpose bucket. You can use it, and based on pricing, we can select it, and it can be used for almost every data. We can say the other one, intelligent tiering. By intelligent tiering, we mean that so you have a S3 bucket, you can put data there, but AWS can track, or you can also configure it that infrequent data can be moved to other tier. So you have it's the same storage, but they have divided into tiers. So frequently accessed data can be can sit on S3 standard, for example, and infrequently accessed data can move automatically to lower tier. If we do that, from user perspective, we may not say we may not see much difference, but obviously, the frequently accessed data will be accessed faster. The other thing is cost will be cheaper, much cheaper, right? So intelligent tiering would mean automatically the frequent access data will be on top and you can access them, and infrequent will be moved on onto lower tiers, right? S3 standard infrequent access, you can see S3 standard IA, one zone infrequent access, one zone IA. Again, these are these are the tiering, right? These are the tiers, S3 storage tiers for, as it says, infrequent access. You can use this for, we can store data here for infrequent, the data which are infrequently accessed, not needed for immediate use, for example. Standard and one zone, again, we'll see the difference while demonstrating the S3. S3 Glacier, right? It's for long-term storage. S3 Glacier and Glacier Deep Archive are for long-term storage. Now, we'll see data as well. After 30 days, we can move, we can actually configure it in such a way that if a file is not accessed for 30 days or for 90 days or 60 days, whatever, days we select, we can move data from S3 standard to Glacier or Glacier Deep Archive, right? From our point of view, from business point of view, it will save cost. So it's basically going to back up in a way sense. Now, with intelligent tiering, you see, if a data is in lower tier and someone wants to access it, it automatically then moves to the top tier. So you can always access it fast. The latency will be low. You can see we can upload, so you can create a S3 just up to one or two line, one or two clicks. You can create S3. You can upload your data, right, in a region, any region, right? Now upload almost any number of objects to the bucket, right? These buckets, these data can then access using URL. They will provide an URL, for example, in bucket path style here. This is the region code, amazon.com, and bucket name, right? You have bucket virtual hosted style URL endpoint as well. So any of these URL, any of these styles of URL, you can use and access your data from browser, right? So the immediate use you can see of this is to host static data or static web. If you just have one page, you can simply host it You can simply copy there and give users URL, right? And they can do. If you have to share some data, you can put in Amazon S3 and send this URL. People using this URL, people can download it, right? Um, the good thing about bucket data or the data you put in bucket S3 bucket is this is replicated across the region, right? So in a region, you may have the on the back end, AWS may have multiple facilities, right? So if you put the data in a bucket, it is actually reflected or um, uh, it is kind of backed up in multiple facilities. So if something happens to your bucket or your data, you can always recover, right? Um, Designed for seamless scaling. Bucket is basically, you don't have to specify in a way size for bucket. You just keep putting things in bucket, it will automatically grow. It automatically scales. And you can say it automatically scales down as well. So the charging, normally, the first line of the pricing is how much data you're gonna put in which tier, right? So if you put 10 gig data, you'll be charged for that 10 gig. And if you want to put like another 10 gig of data in that pocket, you don't have to change sizes. Remember, in EBS, you have to. If you have chosen 10 gig size, then you have to go back. It scales, but you have to do it manually. Here, it happens automatically. That's the difference, right? You can access data from anywhere using AWS Management Console, which we are going to look at shortly, and or with command line interface or with any software development kit. Yeah, with URL, you can access that and download as well. So some common use cases you can see, storing application assets, static web hosting, which I just said, backup and disaster recovery, right? Staging area for big data and many more. So the snapshot you created from Lab 4, right, we just created, can also be stored in S3 for long-term storage, obviously. The snapshot, right? And you can always fetch that snapshot and make it a new volume again, right? This is common use case scenario. You can have S3 buckets. Corporate has a data center, but from computers, from apps, whatever data, from whatever source you actually are generating can be, S3 buckets can be used to store that data. In fact, in some cases, you can store entire EC2 instance as well if you have to back up that instance, right? Pricing, you pay only for what you use, including GBs per month, right? Transfer out to other regions if you have to copy it to other regions. If you have something in bucket and you have to copy in other regions, right? And put, copy, post, list, and get requests. Now, by name, right? Put is basically you are putting something in a bucket. Get is you are accessing that. Like if you want to list, that also gets some charge. So these are, in HTML terms, post and get request. We can actually, we actually do that, and that was, and it will be charged. What we don't pay for, or what is free, is anything you put inside that. Now, anything you put inside a bucket is not getting charged. However, if you keep that, for a month or for a day, it will be charged GB per month, isn't it? So general in AWS, in general, transfer in, you are putting data is not chargeable. However, data out from Amazon S3 to CloudFront or Amazon EC2 in the same region, right, also is not charged, but in different region. So data, if an Amazon EC2 is accessing data from your S3, will not be charged. However, if we are transferring, or if we are if a EC2 from another region is accessing, that will be charges. So basically it's a bucket, right? Stored somewhere. It can be accessed from almost anywhere. right? To estimate Amazon S3 cost, consider the following: storage class type, right? Standard storage is designed for, we said, 11 nines of durability and 4 nines of availability. So 4 nines after 99, 99.49, 99999, right? So they are pretty much, we can say 100%, although, technically it is not. We can use S3 standard infrequent access, we saw, right? SIA, which is designed for, again, same, you can see 3 nines of availability and 11 nines of durability. These are cheaper. If data is not frequently accessed, we can always move it to lower standard, lower storage. We can configure it such that it will go to the lower tier, right? Amount of storage, so the number and size of object we should consider as well while using Amazon S3, right? Request also you see get put, those request gets charged. So we need to plan the number and type of request, how much, it's a tentative data, and how much it would cost. So it's basically planning before using, right, for a real kind of scenario. Data transfer, pricing will be based on amount of data that is transferred out of the Amazon S3 region. Transfer in is free, but we incur charges for data which is transferred out. Right? Now, just to summarize, S3 is a fully managed cloud storage service. We can virtually, this is unlimited storage basically, right? We can virtually store unlimited number of objects. Whatever we put there, it is treated as an object, audio, video, text file, whatever it is treated as an object, as in if you want to modify that object, you are essentially creating a new object or new file, right? We can access S3 from anytime, at any time, from anywhere through the URL they give us. We'll see that S3 offers rich security controls as well. We will see that what controls privacy or security controls we have been given, or we have choice from this. So I've just logged in EC2, AWS Management Console. I have using a free tie-up. Right? So if you want, you can log in as well. And, while we're doing, you can do, while I'm showing, you can do with me as well, with me, right? So for EBS, right? EBS is just an extra hard drive for any of the virtual machine, isn't it? So we had to go here to EC2 to find EBS, the volumes, Elastic Block Store, right? Volume snapshot, you can create volumes and snapshot from here, right? However, S3 is an storage service, or independent, you can say. It's the service. So you simply can search from here, or better enough, find the category. So we'll go and find the category storage. And you have different kind of storage. EFS we are going to look at next. Here is S3. Yeah. Now, that's S3. I store and retrieve any amount of data from anywhere, virtually unlimited storage. Now, so how it works, or the other things you can look at when you're free time, right? These text, although we just explained here. If we want to create, if we want to create a bucket, we can simply create. We can simply click as create bucket. You may have to you have to choose name, but here choose name, there are some, unlike other resources, there are some restriction you can see. Name must be 3 to 60 characters and unique within global namespace. So, for other resources, when we were learning, we just put test demo. This may not work here because someone else might have already taken that name. So we have to try a few times. is what, that's not a problem. And has to have a global limits. Bucket must begin and end with letters, with a letter or number. Values characters are A to Z, that is small case letters and number, right? Period and hyphens. So let's put a number, hopefully a name, hopefully no one has. So taken that demo S3, right? I suspect this name must have taken by other, but let's see, right? Then you have seen the other option is object ownership, right? Control ownership of object to this bucket from other AWS accounts. Now, if we do ACL disabled, which is recommended settings, right? All objects in this bucket are owned by this account, so my account. Others will not be able to access it, right? If we do ACLs enabled, the objects in this bucket can be owned by other AWS accounts as well. So this is the recommended setting, but we are exploring. So you can simply use ACL enabled, right? It will recommend you to disable this ACLs. Access control list is what we're saying, right? We can have access control list configured or written to control the access for this S3. We can see bucket on preferred object ownership. If new objects are written to this bucket, specify bucket on. You can read that, right? I don't have to read. So we are not using the ownership just to me, but ownership can be taken by others as well. That's the option. Now, that's important here. You see, block public access settings for this bucket. Now we have a few settings here. If you simply click this one, you block public access from anywhere. So if you do that, you'll not be able to see those things from browser. They will give you an URL, but you'll not be able to see these things from browser, right? So we'll see that URL and So for now, as a recommended, we'll just put block all services. Now we can read, right? Here, block public access to buckets and objects granted through new access. So if your application design need any of these, not all of them blocked, but a few of them blocked, you can select that as well. Other property, you can see bucket versioning, right? Versioning is basically you upload a file, then you make changes and you upload. So you can keep both version 1, version 2, version 3. Source control, right? Some of you, or I'm pretty sure you guys have used Git, right? In Git, you can version. So if you upload file, same file next time with some changes, you will have V1 and V2. So you can implement versioning as well with this one. I have just disabled it for for this purpose. You can simply enable it. So in fact, we'll enable it anyway. We'll see if versioning works or not, right? Tags, you can put tag name for, we know the idea of tag, right? For others, other resources. So same idea here applies. Name, default encryption, right? We can encrypt data. The data is encrypted. Server-side encryption automatically apply to new objects stored in this object. If you want other encryption, SSC, KMS, for example, this is basically they used AES. Now key, whether you will generate or you will use key generate from the key management system of AWS. That's the only difference between these two, right? AWS key management service, or you can, S3 manage, you can give your key as well. There is an option that has to be AWS compatible. Now, for pricing of these options, we can always go and see what prices they say, right? Bucket key using an S3 bucket key for this one reduces encryption cost. So these are cost reducing considerations. In advanced settings, you can see, right? Object lock. Currently, by default, it is disabled. Store objects using write once read many warm model. So basically, once you have a static website, you upload it there, and you can actually lock that object, the website, so that no one will be able to, although they have access, but they will not be able to change. However, they can browse the website, right? Okay, so let's create the budget. Sorry, bucket, not budget, but okay. So it is not letting me, right? This is a common name, demo S3, as I suspected, right? So let's make it something very different. NI6504. Sorry. Oh yeah. Yeah. So, but even let's see, and it tells you at the end. You did you notice? Not initially. So okay. For capital letters, right? So let's put NI6504. And I'm pretty sure no one has taken this name. Wow, reasonably sure. So demo S3 anyways. Yeah. Create bucket. Okay, so no one has taken that name. It has to be globally unique. So um, you know, we'll have to do some name searching there. Yeah, so that's your bucket, right? Demo NI6504. You can simply see this bucket. You'll have currently it has no objects. Let's upload some from the add files from our PC. Right here, can I find some picture maybe? Screenshots. I hope this is not. Yeah, so upload this PNG from my computer or this computer will simply do upload, right? And this is just 19. You can see 19.7 KB. So it's expected that it will do fast. Even for bigger files, although it will be fast, right? So we'll just refresh, go back to our bucket, right? Demo bucket, and if you see, here it is. It's already there. Now, if you select this, see, you get copy S3 URI. So that's up to S3 URI, URL indicator. Now this URL, yeah, if I copy here, right, and browse, it should not work though. Yeah, it should not work. Why? We have blocked public access to this one. If we allow public access, it should work. How do we do that? Remember one thing also, we said that, objects within S3 can be accessed individually. So S3 allows us granular access now or configured individually, right? So for this only, for this particular object, I can actually, change things like properties. Well, properties, they don't have much things to say. Storage class, we can change. Amazon S3 offers a range of storage classes, right? Designed for use cases. The storage classes with intelligent tiering, other tiering, permissions, right? So permissions control has been given to, we selected that, right? Access control is ACL. We can have new ACL create, right? Object owner, that's my account. Everyone is public access, right? To give all users read write all, we can configure with purpose versions. That's the first version here. We have not uploaded any other version. That's an image, so we can't even see, I guess, right? Let me create a notepad. Right? And I'll upload this just to see the versioning thing which works. Yeah, desktop. And we have, yeah, let's upload this notepad file. It's uploaded. isn't it? Yeah. Upload. Right. Here we have. Now let's make it. Let's make some changes to this file. Where was the file? Here. Right. So this file was uploaded, and this had some SQL injection query, I guess. Something. I'll just add hello. Just checking the versioning of S3. And please excuse my spelling. That's not what we're doing here. But anyways, right? Yeah, it's okay. We'll save it. Right. So this is a new version of the same file. And let's upload that. Upload. Right. I remember we had enabled versioning, so it should work. Add files. Right. Now, when you are uploading, just to see, these are options here. So either you are using standard tier or standard frequently accessed data more than once a month with millisecond access. So very fast, right? And it is replicated within, you see, more than or equal to 3 availability zones. It is available within the region. The region we have selected, in this case, I have selected Sydney, right? You can use intelligent tiering as well. So data, if we have data, like our file is simple anyways, but data with changing or unknown access patterns, right? We can go intelligent tiering. Why? Because it would move your infrequent data to lower tier and it will cost us less, right? You can see the pricing, per object fees applied, object up to 120 case. We can look at pricing those things. Standard IA, which we are looking at, right? Infrequent access data once a month with millisecond access. Again, it's a general purpose. You have this tier will be available for more than 3 availability zone. If your region has more than 3 availability zone, obviously, right? And minimum storage duration is 30 days. After 30 days, it can go to another lower layer as well, right? Similarly for IA, one zone IA, recreatable infrequently accessed data once a month with millisecond access, right? Again, for 30 days per GB. Fee applies. You have Glacier instant retrieval, so long-lived archive data access once a quarter with instant retrieval in milliseconds. So you can use this store where you can store data which you are expecting that it will only be accessed or used once in 3 months or 4 months, right? We can always store all these things in standard tier. However, the cost of standard tier is higher than obviously these things. So Glacier flexible retrieval. So formerly it was known as Glacier. Long-lived archive data accessed once a year, right? With retrieval of minutes to hours. So it might take minutes to hours to retrieve data, right? But you are only needing the data once a year. So it's wise for us to not pay much for that data, right? Similarly, reduce redundancy, Glacier, deep archive, you can see, right? Non-critical, frequently accessed. We always can read and do that, right? Server side encryption, we have not specified encryption key. We can basically, as I said, specify encryption key as well, right? If we know, AES, we know that. I mean, this class knows that. The hash checksum used to check data integrity, right? There are several algorithms you can see, SHA-1, SHA-256, right? And this, again, hash can also be pre-calculated, hash can also be provided. We know uses of hashes, right? Do we? Yes, we do. And we can simply here while I have selected this file, we can simply upload now. Right? Now this you can see, right? This one should be the new one, right? Versions you can see. See, that was the old version. Or this is the current version. This was old version, 10.12 and 10.20. So you can, if you want to recover this version, for example, you can recover this, download or recover this version as well. You can simply download, right? It's in bucket. So this is our new one. So versioning is also we enabled it, so it definitely work. So we can make use of versioning of our data as well, or files. With permission, if we can change permission, and this is happening at granular level, right? Object level. You can do permission, set up permission, all those things for Pocket itself. That's one layer. Another layer, for each data, you can set permissions up to your need, as according to your need. So this is a simple demo, if I may say, for S3 buckets in Amazon, right? So buckets is a storage device and used for storage, as simple as that. There are multiple tires which we read, according to our need. We can change tires. The intelligent tiring will do automatically. For others, you have to configure it. But then why we do that? To save some cost for data which is not frequently accessed, right? So it's a simple demonstration for S3. Now let's move to EFS, Amazon EFS. Or before that, if you have any question. Right, so next we look at is what? Amazon Elastic File System, right? Or file system, NFS. Now, those who are familiar with NFS, Network File System, is simply cloud or AWS cloud equivalent of network file system, right? So we can configure stacks of hard disk, stacks of storage, and connect it to a network, isn't it? In on-premises environment, if you have seen, or if you have come across anywhere, if you go, in fact, to the next room, that's called 606, I guess. Yeah, you have lots of switches there, routers, as well as this, and lots of storage devices connected with NFS, and those storage devices are shared. We used to have S drive, a few other drives, which was used to store academic softwares, data, all those things, and was accessible to you guys, to all of us. So any SOIT user, but the storage is there. The drives are gone. They have taken it out, but the storage is still there. So you configure a storage and connect it to a network where every network user, that is, in our case would be students, tutors, and anyone, can use that storage for their need, whatever purpose they do, right? So that's on-premises environment. Now, in Amazon Cloud, you are just doing the same, right? For that, to configure EFS, to make use of EFS, what you need to do? You need to have a network. What is the network here? The VPC, remember, virtual private cloud, where you configure subnets and all those things. So you configure a VPC and add EFS. The size and other things is according to your need, right? So that's the kind of introduction to Amazon EFS file system, right? So features of EFS, you can see file storage in AWS cloud. It works well for big data analytics, media processing workflow, and content management. web serving, and many other things, home directories, all the things, right? The scaling here is petabyte scale. So from terabyte to petabyte scale, right? Low latency file system, latency will be low. It's a shared storage. Yeah, it's a network file system. So it will be shared storage, shared among the network users in that network, right? NFS thing has elastic capacity. We know can be increased, can be decreased as we need, right? Uses or supports network file system. So if you have to access the EFS device or EFS storage, which you have configured, your client needs to have NFS installed. That's the only difference. Otherwise, the mounting process and everything is exactly same as we did for EBS, Elastic Block Store. Yeah, I was doing a demo and you guys did a lab on that as well today. So I hope things are a little bit clear. And is compatible with all Linux-based AMI for Amazon EC2. In fact, it is generally compatible with any Linux version. If you want it to use with Windows, you can't use it directly, but you need Samba share and all those things, right? Configured. Then you can use it from Windows as well. For Windows, there is a legacy kind of storage, FSX, which I had mentioned yesterday. We can look at when we configure this in AWS console, management console, right? So you can see that's the VPC. So, for network file system to exist, you need to have a network. In cloud terms, in AWS cloud terms, our network we configure is virtual private cloud. Now, see, in a virtual private cloud, when you configure, you'll probably have you'll surely have multiple availability zones, right? And these availability zones will have subnets as well. In VPC, you configure subnets. So let's say in this VPC, you have 3 subnets, public and private. All are private here, right? These 2 subnets here, private, and as well as, well, only 3 private subnets, right? Across. So we generally, when we create subnets, we try and put them across availability zone, isn't it? We don't want to put multiple subnets in availability zone, although no one stops us to do that. For redundancy purposes, we do that. Now, you can create a EFS, you can see elastic file system here, and you have to create mount targets. In fact, we don't have to create, AWS creates for us. So this shared, it's a shared, right? So it's mounted here in each of these subnet. You can see, right? Single time for one subnet, it you have to create, or AWS create mount target once, and all the network, all the EC2s, all the resources from that particular subnet can access that elastic file system, EFS storage, which we have configured. So the steps would be, we can create our EC2 resources and launch Amazon EC2 instance, right? So create your EC2 resources and launch your EC2 instance, create Amazon file system, create mount targets in appropriate subnets like here, wherever that is sitting, your EC2, wherever you have kept. From that, it can access, obviously, it needs mount targets here. So for example, let's say we have availability zones D, right? One more additional, and we have not created mount target from that EC2, even with being in the same VPC, won't be able to access this. The point is to create mount target, for a subnet, and from that subnet, you can access it. Connect your EC2 instances to the mount targets, verify these resources and protection of your AWS accounts. So these were the steps, right? Some of the resources, file system, you have mount target that is basically automatically created. If you know what you're doing, you can create mount target yourself, which is for a little bit more experienced user. Subnet ID, security groups, all these things needs to be considered. You remember that subnet ID, you are creating a mount target for this subnet ID, right? This subnet and this subnet ID. So subnet ID is needed. It's important. Security groups for each of the resources. Also, we can configure, we can give this security group to to each of these mount target, or each of these same security key we can keep um, for the mount target as well as our subnet or resources within subnet, right? Within that security group, remember, we need to specifically allow NFS access. So TCP traffic and port is, I think, 2043. Whatever, we can find it from there. For NFS, for EC2 to be able to access the EFS file system which you have created, right? For a validity zone, you have to create this mount target must be in the same VPC, right? We can create multiple mount target in multiple subnets. Tag, again, key value base, So to summarize, EFS provides file storage over a network. EBS was for, creating EBS volumes and attaching for EC2. S3 general purpose storage is just a bucket any EC2 or even other things can access. You don't even need EC2 as other things if you are just doing static web hosting. You just keep your page there, give URL to your users, they can do that. You can share files and everything, right? That's a kind of general purpose storage. For network storage, as NFS and other RAID, other systems are there for on-premises, AWS gives us option called EFS, which is a network file storage. Right? Use cases include data, big data analytics, media processing, content management, web surfing, and many others. Right? It is fully managed service that eliminates storage administration task. But fully managed by AWS, so we just have to configure, give proper access, and that's it. Right? Accessible, similar to S3 and EBS from console API or the command line interface, scales ups and down as files are added or removed, and you pay for what you use. So basically, automatic scaling here. Scales up to petabytes, as we saw that up as well. We don't have to worry about. So initially you set up and then you keep on adding files. It will automatically scale. And if you remove, it will automatically shrink, right? Elastic, it is elastic, but in some cases elastic we have to configure, but here it happens automatically, right? Let's quickly look at Glacier as well. Amazon S3 Glacier. Now we already might have some concept because while we're looking at S3, we talked roughly about S3 Glacier as well. While doing demo also, we saw this diagram, right? Amazon S3 Glacier is again is a bucket, right? Object level storage, object type storage, but for long-term storage, for backup kind of purpose, right? It's a data archiving service, you say, right? S3 Glacier is an S3 simple storage service, but for usually used for data archiving and is designed for security, durability, and extremely low cost. So security and durability basically is common for other tires or other S3 as well. But this one incurs very, very low cost, right? It is designed to provide 11 nines of durability for objects, right? Supports encryption of data in transit and at rest through SSL or TLS, right? Much like web. That's why you can access directly data from web. There's something called vault lock feature, enforces compliance through a policy, right? Is an extremely low cost solution or extremely low cost design, works well for long-term archiving. There are options for access or how fast you can access data, right? Or the data or the archives you have put in S3. Glacier, you have expedited, standard, and bulk, right? Retrieval times range from a minutes to several hours. Right? You can see here in this picture. So you have an Amazon S3 bucket. You can set it up for some data. So for data who has not been accessed for 30 days, for example, right? To go into the S3 Glacier, right? And you can set up, for example, that if it is not accessed for 5 years, automatically delete, or 3 years, it automatically deletes. So you can, or we can all set it up like that, right? It's a low cost data archiving and long-term backup service, right? We can configure lifecycle archiving for S3 content to Amazon S3 Glacier. So archive after 30 days. So no one is accessing. Let's move it to S3 Glacier. And then if no one is using it for 10 years, 5 years, we can delete as well. So some that kind of use cases. We have retrieval option here. Standard is 3.5 hours. Now the pricing obviously will be different here. Bulk 5 to 12 hours, right? And then expedited is from 1 to 5 minutes. Obviously, for expedited retrieval, you will pay more than the other two retrieval options. Some of the use cases, media asset archiving. So, anything archiving, as I said, right? Healthcare information archiving, right? Regularity or compliance archiving, scientific data archiving, if you have lots of data, digital preservation, magnetic tape replacement. So yeah, earlier, you may have hard drives, which has a lot of data. You think that you may need, and they are in magnetic tape disks. It's better to just keep in S3 Glacier now, right? For safety purpose and other things, right? Now, how do we use S3 Glacier? So, RESTful web services, we can use just RESTful web services, Java or .NET SDKs. So from your Eclipse or NetBeans, those kind of IDs, as well as for .NET, Microsoft Visual Studio or Visual Studio Code, right? Also, REST API, also with Amazon S3 with lifecycle policies. So we can set up those lifecycle policies as well, right? So lifecycle policies, as you can see here, this Amazon S3 lifecycle policies enable us to delete or move objects based on age. We can set it up. For example, right? This is S3 standard, the bucket we just saw, right? And that there is some data. You can set up lifecycle policies such as after 30 days, it should move to Amazon S3 standard infrequent access. Right? Here, you can keep it for 60 days, right? If someone, for example, right, if someone access your preview to MP4, it will automatically again then move back to the standard access. And you will get low latency retrieval anyway. After 60 days, you simply can move to Amazon S3 Glacier, right? You can set it up like after a year, you can delete, right? So we may not appreciate this kind of life cycle policies and all those things. Why would we do that? Well, simply because we have not been working with real data in a real environment, right? In real environment, you'll have lots of data, and this kind of thinking we can do to save cost. The primary, objective is to save cost. The other is to have an efficient kind of professional arrangement of your data and data life cycles and everything, right? Storage comparison. You can see data volume for S3 and Glacier. We have no limit. Latency, millisecond for standard S3, but minutes and hours for S3 Glacier. Right? We can do expedite, within minutes we can bring it, but still, right? So item size 5 TB maximum, 5 terabytes. So one of the item, right? There's no limit, but basically to upload one item, it cannot be more than 5 TB. Here, it cannot be more than 40 TB. obviously incurs high cost, S3 incurs high cost, and S3 Glacier incurs lower cost. Build requests, put copy will get charged here, upload and retrieval will get charged, right? Retrieval pricing per request, it's per request and per GB, right? See, we can use server-side encryption. That's TLS basically, right? Using TLS. So corporate data center you have, this is Amazon Cloud. Using HTTPS, you can access either of these buckets. So TLS can be set up, or it's already set up by default if you select the option while creating, right? Where application must enable server-side encryption. We have, that was the default option, and we could change it to other option, but the options were mainly about keys. Who will generate keys using AWS key management or yourself, those things, right? Security with S3 Glacier, we can use IAM to control access. So who to give access, what kind of access we going to give using identity and access management. We can use obviously encryption option, encrypts data with AES 256, pretty good encryption scheme. So far as of now, data we don't know, but as of now, it's a good encryption scheme and data will be secure there. While doing this encryption, you would need key, and which will be which can be managed by S3 Glacier. They will manage key for us. Yeah. To summarize, S3 Glacier is a data archiving service that is designed for security and durability, and extremely low cost, right? S3 Glacier storage option, the price of that S3 Glacier can vary across regions. So it depends on region. It is extremely low cost. Design works for long-term archiving. The service is designed to provide 11 nines of durability for objects that are actually uploaded to that, right? There are a few case studies, you can say some small case studies, which well, it would have been fun to do if we had longer people to have a group and then start, because there are a few things here which you'll need to research and then answer this question rather than randomly answering the question based on this diagram. For example, we have not talked about Kinesis, right? We know API gateway, but we have not fully talked about API gateway as well. You know AWS Lambda, you know container, but you don't know Kinesis. So you have to search what Kinesis does, then answer this question. So for now we will leave it, but let's go and see the EFS. We have enough time. I'll quickly show EFS as well. Now, like S3, it's an storage service. So you can find it from here, EFS, yeah, or go proper, well, not proper, but go this way as well. Find storage, EFS, yeah, create a file system. You can see here, you can consider the pricing and all those things, create a file system, name, right? Demo EFS, maybe, yeah. Now it's a network file system, right? So network needs to be there. I have not created VPC. It's always recommended to create your own VPC, before you use it, right? So this demo network file system or EFS volume you are going to create, file system you are going to create, put in default VPC. We have a default VPC, you can put it here, right? And there are some recommended settings which we can actually edit For example, throughput mode, transition into infrequent access, IA, 30 days since last access, yes, right? These are editable options. After creation, you can see the transition into archive, 90 days since last access. So it will go to those, um, infrequent access storage, transition into standard, none. These things can be editable after up to our, and you can make it 40, 50, or 0 up to our need, right? Whatever our need is. Let's see customize option as well. So file system type, it's a regional. We can set it up to one zone as well, which will provide continuous availability to data within a single availability zone within an AWS region. So if our network, our VPC is set up within, as a node and has only one availability zone, or we want to create a file, um, a file share which will only sit in a particular availability zone, we can go for this one. Otherwise, regional will basically available across all region and available across all availability zone within that region. Automatic backup, again, this is an option you can select or not select, right? Although, if we don't select it, they recommend to create a backup policy for a file system, right? So let's keep it that option. Lifecycle management, you can see transition into infrequent access, 1 day, 7 day, there are options, right? So you can select as per our need, 1 day, 7 day, 14 days, whatever. So basically, if the data is not accessed for the days selected, it will move to infrequent. Similarly, it can go to archive as well. Why we do that? To save cost, right? To save the cost. Transition into standard on first access, you can select, right? If you have moved it to archive, for example, after 90 days, right? But if someone wants to access that data, we want it to move to standard again. We can select it on first access or something like that. Or none. You don't want to remove, there could be a needs that someone actually browse that, but we don't want to move because we still feel that no one will need to access that. You can customize encryption settings, right? Using a KMS or key, enter an ARN from somewhere, create an AWS KMS key. We can do that for security purpose. Throughput mode, you'll by default is enhanced, right? Rusting provides throughout scales and all those things. According to need and pricing, we can select either of this option. Elastic, yes, it is recommended use this mode for workloads with unpredictable IO. With elastic throughput performance, automatically scales with your workload activity and pay only for the throughput you use. We can provision as well. In this mode, if we can estimate our workloads, which is a very difficult task, and experienced users can only do that. Right? Performance mode, either general purpose performance and max IO, the maximum input output performance per second would, right? There is there, but probably because it's a free tier account, so they have not allowed us to select. Right? Next, right? Remember that figure? Where was that figure? Yeah, this one. I'll just show you this one, right? This one, you see? So this is, you have kept elastic. Again, this will depend on your design and need, right? But this is a generic use, a sample example you can see. You have kept your EFS file system here, created 3 mount targets for each of these availability zone or each of these subnets you can see, right? Here. So it's a network file system, should be useful for entire network, but depends on what kind of access you want to do, who you want to give access, which subnet, we can always manage it, right? So here, that's what we can do here, right? We can create mount targets. So for in this availability zone, This subnet, it's a default. I have not created any subnet, so you know, I'll leave it as default, but we have created, we can always select that on this. So this is only allowing me to do that. AP, Southeast 2A, that's fine. Subnet, this subnet, right? IPv4 only or IPv6 only or dual stack, what kind of, the security group, a default security group, right? You'll not be able to access because default doesn't allow us. Well, I think it allows every traffic, so we don't have to allow NFS, network file system port. Here, we can add to another availability zone, right? Subnet, IPv4 only. We can remove if you only allow it to only one availability zone and one subnet, right? We had 3, so by default is 3. I'll just leave it like this. Next, file system policy, right? Prevent root access by default and other things. We can also write code for policy. In IAM, we did see creating role, creating new policies, right? For that, we need to write code for that. If we need specific policy, right? Other option, we can always do that. Now, review and create, you can see that's a demo is elastic, yes. You can remove and create, you can put a tag as well, mounting, all these 3. Here, see, all the availability zone we have mounted, we have 3 different subnets here, private or public, depending on our news, right? So we have mounted in 3 subnets. So if almost depending on the permissions we configure later on in JSON, almost every computer, every resources in that subnet can access this network file system. You see, it will take some time to create, right? Now, unfortunately, I don't have any time to create EC2 and show you accessing a EC2 from that subnet, right? We will have a few minutes left. But I recommend that as an homework, create a EFS file system, right? And create an EC2 within that VPC, any subnet you like, and show me that you can access that EFS from your EC2, right? Now, hence, you will follow same steps like you did in lab 4. Similar steps, but lab 4 was only concentrated, right? Only concentrated as in you only created an EBS volume attached to EC2. Here, you have to consider a few things. You have to create a VPC. You can use default VPC as well if you know what you're doing. Create a VPC. Within that VPC, you'll have a few, obviously, availability zones, right? You will create subnet. General practice is you keep subnets in different availability zones. So if you have 2 subnets, keep in A, availability zone A, and B maybe, right? So that you can do within that subnet, you can create an EC2, right? Create EFS for that VPC, entire VPC, and allow those EC2 resources to access this one. Now, creating VPS, we have seen this is recorded, so I'll keep it. I'll upload it to YouTube soon after this class. Right, you can follow that. Combine your lab for skill which you learned and what we saw, and please do that. I would have shown that, but we have only a few minutes left. That so do that. So that kind of ends our storage module.